Today we are going to look at one of the classic multi-threading problem of computer science, which is producer-consumer problem. So for explaining this, we'll use a simple bakery example that will walk you through, and then we'll go through the C++ code for the same. So what's the bakery problem? We can just think of a bakery like the baker, which is who is a producer, who he or she makes a bread and puts it on the shelf, and the customer or consumer takes the bread from the shelf to eat. So there's a two rules to keep the things running smoothly. The first one is the baker doesn't add more bread if the shelf is full, and the customer should doesn't take the bread if the shelf is empty. So and see, so basic definition is the producer consumer problem is a classic multi-threading synchronization problem where producer generates data and put it in a shared buffer, and consumer takes the data from the buffer and process it. So what problem occurs, like producer must not add when the buffer is full, means that shared uh, buffer is full, and consumer must not remove when the buffer is empty. So without synchronization, race conditions can occur, like consumer is trying to get something even if the buffer is empty, or producer is trying to put something if the buffer is full. So in those scenarios, race condition will occur. So how we are going to solve this problem is using mutex. Mutex will help us to ensure only one thread access the buffer at the time, means either producer or consumer will access the buffer at the same time. And second thing what we'll use is a conditional variables. So using that, the producer, so we can make the producer waits if the buffer is full, that producer should not put more things if the buffer is already full, and consumer should wait if buffer is empty, means if there's nothing in the buffer, then consumer will wait to so that there's something in the buffer is available. So we'll write a C++ code for this. So first thing we'll include the basic headers. Yeah. So we are including this queue because we'll create a queue as a buffer. We'll consider queue as a buffer, and threads for producer and consumer, and a mutex for locking, and conditional variables for signaling. So after that, uh, so we'll create a queue which will work as a shared buffer for us, and then we'll create a mutex to lock the buffers, and a conditional variable for signaling, like if producer keeps put something, and then if it finishes its works, then it will inform the consumer, and if the consumer finishes its works, then it will inform the producer regarding the same, and vice versa. So how the producer will work? So this is the code for producer. How producer will work, like we have created a buffer of size 5, means we have created a buffer as q, and we are giving a maximum size of 5, means at one time there will be only 5 things in the buffer, and we are running the loop for 10 things. I'll explain how it works. When we will run, we will see. So first the producer this thread starts running, it will lock the mutex, and then this is the wait function, means conditional variable. It will wait till our buffer size is less than maximum size. If it is increases the maximum size, or it becomes equal to maximum size, then it will just directly notify the consumer. And for other times we are just pushing the I value, means 1 to 5, 1 to 10, and we are just printing that, yeah, we have produced this number. And let me show how consumer will work. So this is our code for consumer. Same way it will also go from 1 to 10, and first we'll log the mutex before processing, and same way we'll take a conditional variable, so it will keep on waiting till our queue is empty. If the queue is empty, then it will inform the producer that yeah, I'm done, you can now work on use the shared buffer. What we are doing here in the consumer, we are just taking out the front value from the queue, and we are popping it out and printing that yeah, this is consumed. After that, we are just notifying the producer. And in the main function, we'll not do anything. We'll just create two threads, producer and consumer, and we'll just join both of them. So let me now compile this program. It compiles fine normally, and we'll run it. Yeah, see the output. What's happening? So as our buffer size, maximum size is 5 only here. You can see line number 11, buffer size is 5. So what we are doing, what our producer is doing, well, see, we are calling the T1 first for producer. So it goes to the producer, takes the buffer first, and it logs, and it will work till the maximum buffer size is reached, that is 5. So till 5 it will just produce directly 555, and this condition reaches, means equal to maximum size, then it will notify the consumer. Then consumer will take the buffer and it will consume all the 5 resources, and hence this is empty now. All the 5 resources are consumed, it popped out, so it will become empty. So this conditional variable will come into picture. It will notify the consumer producer that yeah, I have already consumed all the 5 resources whatever in it. So now it will again go to the producer, and now producer will again generate, put the 5 elements from 6 to 10, as we are running our loop from 1 to 10. So 6 to 10 it will run, again it will produce, then buffer size of 5 is reached, so it will break, and again it will notify the consumer, and consumer will consume all the 10 resources. So this is how the producer consumer problem works without any hassle.